You know that feeling when you're wearing shoes that are, like, just a half size too
Oh,
small?
yeah. It's brutal by the end of the day.
Right. You can walk in them, sure, but your back aches, your feet have blisters, and you just know you weren't meant to move like that.
Definitely.
Well, what if humanity's entire existence on Earth is exactly like wearing those shoes? Today's deep dive is exploring this wild scientific hypothesis. What if our chronic backaches and sunburns are actual bioevolutionary proof that we weren't meant to live on this planet?
It is a completely radical reframing of human history. We're looking at the exogenesis theory.
Okay, let's unpack this. Because the idea that our true Eden is an exoplanet is mind-bending. But if you look closely at human biology, it's totally different from indigenous terrestrial species. Like, we struggle constantly with Earth's gravity.
Exactly. Think about our chronic back pain or spinal disc herniation, and even the severe complications of human childbirth.
Which are notoriously difficult compared to other mammals.
Yeah, they really are. And these anomalies suggest our skeletons actually evolves for a lighter gravity environment. Basically somewhere between 0.8 G and 0.9 G.
Oh, wow, so just slightly less gravity than we have now.
Right. In that slightly lower gravity, there's less spinal compression. So our skeletal structure suddenly makes perfect biomechanical sense.
That is so wild. And then there is our internal clock, right? Human bodies naturally default to a 25-hour circadian rhythm.
Not Earth's 24 hours.
Exactly. If we spent millions of years evolving here, wouldn't we be perfectly synced to a 24-hour day? Instead, our biology implies a planet that rotates just a little bit slower.
Yeah, and we are incredibly vulnerable to our own sun, too. Birds and lizards don't need, sunglasses or SPF 50 to survive a day outside.
We absolutely do. I burn instantly.
Right. So if we evolve here, wearing those too small shoes, why are we so poorly adapted to our own gravity and our own star?
Well, the source material tackles this, and what's fascinating is that this specific vulnerability points to a progenitor world orbiting a very different kind of star. Specifically, like a K-type orange dwarf, or maybe a late G-type star.
Just to translate that for a second, our sun is a standard G-type star. So a late G-type or a K-type would be slightly cooler and gentler, right?
Precisely. They emit significantly lower UV radiation, and that perfectly matches our delicate skin.
That makes a lot of sense.
Plus, they offer billions of years of stability without the violent solar flares that tend to strip a planet's atmosphere.
Okay, so our biology demands these incredibly gentle, specific stellar conditions. But here's where it gets really interesting. How did this hypothetical planet protect us from whatever radiation was there?
Right, the shielding.
Yeah, because there's this ancient biblical description of Eden being guarded by a flaming sword turning every way.
And if you translate that ancient metaphor into modern astrophysics, it perfectly describes a robust, rapidly spinning magnetosphere.
Like a giant magnetic force field.
Exactly. That's a magnetic shield generated by a planet's spinning liquid iron core. It constantly turns and deflects the literal fire of stellar radiation and solar winds to keep the atmosphere from getting blown away. But hold on, I have to push back on the physics here for a second.
Okay, go for it.
If we're orbiting close enough to a cooler star just to stay warm, wouldn't the planet's rotation just lock in place? Like, wouldn't the star's gravity force it into a tidal lock?
Where one side is permanently baked by the sun and the other is frozen solid.
Yeah. I mean, how does it keep spinning?
Well, this raises an important question about atmospheric physics. The hypothesis proposes a mechanism called asynchronous rotation.
Okay, how does that work?
Basically, this Eden would need a thick 1 to 3 bar atmosphere. Since 1 bar is the atmospheric pressure on Earth at sea level, we are talking about an atmosphere up to 3 times thicker than ours.
And a thicker atmosphere somehow changes how the planet spins?
Yes, because it creates thermal tides.
Ah.
The heat from the star causes that thick atmosphere to expand and shift, which creates massive atmospheric friction.
Oh, I get it.
Yeah, that friction provides enough torque to keep the planet spinning, resisting the star's gravitational drag.
Wow.
Add in a single-piece solid crust, which means 0 earthquakes, by the way, and a sizable moon to prevent wild seasonal wobbles, and you have a perfectly stable paradise.
Okay, so what does this all mean for you listening at home? The next time you look up at the night sky, could you actually be looking at your ancestral hometown? Where exactly are the coordinates for this world?
Well, if we connect this to the bigger picture, ancient texts consistently position the path to the divine, or the origins of humanity, as heading west.
But in space, what is west?
In celestial mechanics, west aligns with the solar antipex. That is the exact direction trailing our sun's motion through space.
Wait, so we literally look behind where our solar system is moving.
Exactly. And spectroscopic hunts in that specific region point directly to candidates like the Tau Ceti system, which is 11.9 light-years away.
Or even Alpha Centauri b. Both of those feature the stable stars and multi-planet architectures this theory requires.
It's honestly a fascinating way to interpret the astronomical data.
It really is incredible to think that our biological quirks, our bad backs and sunburns, might actually be a physiological map to the stars.
It changes everything about how you see yourself.
It does. But before we wrap up this deep dive, I want to leave you with one final lingering thought. There is this ancient description of the 4 rivers of Eden branching out to water the entire garden.
Right, the 4 rivers.
What if those weren't terrestrial rivers at all? The hypothesis suggests they could actually describe an advanced planetary irrigation system designed to circulate nutrients globally.
Which implies an entirely different level of planetary history. Like, it wasn't just natural.
Exactly. If that is true, was our ancestral garden a naturally evolved exoplanet? Or was it a biologically engineered world? Maybe we're all just waiting to take off these tight shoes and finally walk on the world we were actually made for.